Hello, it's Professor Welch. Let's progress now to the development of our flowchart, or let's use Raptor to execute our logic. So the situation that we have here is we want to read the problem statement very closely, as we said before. We want to revisit the logic here, and the logic allows us to enter the loan amount and the number of payments. Okay, so the total loan amount and the number of payments are what we ask, and based on that, the program calculates the interest rate, and then from the interest rate an equation is used to calculate the monthly payment. So from reading this problem statement very closely, and we need to, or we don't know what the program is supposed to do. So again, the logic is we ask for the loan amount, we ask for how many payments, we do some processing, that's the P part, and then we output the loan amount, the number of payments, the monthly payments, and the interest rate of the loan. And we'll see the logic here in a second. A couple of points: make sure you look at the other requirements, and we want to use comments. Comments and documentation is tremendously important. We want to test and debug the program, so you must work the program through by hand as you are gaining better understanding of what's going on. You never want to write code unless you fully understand what the logic is, because then what are you writing the code for? You don't know what the logic is supposed to be. The program must execute and produce correct output, and read this page again over and over to cover all the requirements. And that's good practice for any kind of a programming project. Okay, so returning to the top, we want to input the data, we want to process the data, and then we want to output the results. So let's see what we have going on Raptor. So here we have Raptor, and as we're working in Raptor, we want to have a discussion on sort of the logic that we work through. First of all, we use IPO. So here we have our main program. There's our start, there's our end. Here's our inputs. This is where we actually get our inputs. There's some administrivia here, or some basics here. Here's our process. So these three blocks here are our process. And here's our output. So we've divided our program up into IPO. And then we delve into the I, we delve into the P, and then we delve into the O, which is pretty straightforward. So let's see how we would do this. Now this symbol right here is a call to a module or a submodule. We'll call it a module. So as you see these arrows, that means the program control for the program leaves the main module, which is what this one is here, and it progresses to the module that's indicated right here, which is initialize variables. And we can see the logic that's contained within each of these modules as we click on the specific tabs up here. So let's talk through this. The first module is to initialize variables, and that's best practice as we work through all of our programming assignments. The variables I know to initialize are the ones that I took from the problem statement. And you can see we have the loan amount, now I ran this so you can see the variables that we have here. There's the loan amount, and then there's the num payments. So let's run it for a second and see what happens. Now notice it's going to start here. As it hits this module, it'll move to where this module, the module call is, so it'll move to initialize variables. So let's step through it. So it goes to the start and initialize the variables. Now notice it's stepping through this module. The only purpose is to initialize variables. And then at the end, it will return program control back to here. Now it prints welcome, and I'll pause that right there. So notice I have another module. The only purpose is to say hello and explain what the purpose of the program is. And then we'll proceed back to here, and notice what I've done is I've gotten to the point where I want to select input or get input from the user. Now let me go back to that, because we want to see what this will do. So let's go back to this. Okay, so we're initializing our variables, no problem there. Then we're going to print our welcome. You can see that. Then we're going to get our payments, and then I'm going to pause it. Okay, So when we get our payments, that's when we're getting the number of payments from the user. And this is the first place that we start to put in some logic. So we ask the user for the number of payments. It must be between 6 and 48. How do we error check? We error check like this. If the user gives us an invalid input, we ask them again. So let's say they give us the number 5. So the user gives us the number 5. We enter the loop. The logic for continuing in the loop is right here. And this says if the value that was received is in range, which means it's good, you just go down here and you exit the loop. If the value that was given here is not within range, which means no, it's not within range, then you go back, then you execute the structures that are within the loop, or the blocks that are within the loop. So if the user enters 5, 5 is not between 6 and 48. So this branch is taken. And at this point it says, hey, the value for your number of payments is out of limits. Then it asks for the number of payments again. If the user then enters 50, now num payments is 50, we go back in the loop. 50 is not between 6 and 48, and so it's going to ask us for another value. So we'll step through this, and notice I'll pick 5. And as I pick 5, we're going to see our error over here. The value for the number of payments is out of limits, and in this case we'll pick 20. We'll put 20 in there, and it'll step through there. You'll see it's down here now, and it gave us the number of payments over here. And now we're back into the main program. So notice we have some administrative work, declaration of variables, say hello, and now we have our inputs. And the inputs that we had were the number of payments, and based on the number of payments, now the logic that I use, the approach that I took in my solution doesn't need to be yours. There generally will be fairly parallel because we need to capture the same logic. But notice this here. What I said is if the value for the loan is in this area, we call it a small loan. If the value for this area, the loan is in this area, we call it a medium loan or a mid loan. And the same thing, we call this a large loan. So notice the logic that I have here. So I said that if the value of the loan is between 5 and 2,500, so say it was 2,000, then I'll calculate the payment for a small loan. If I add the value of the loan for let's say 7,000, then it's between 2,500 and 10,000. So is it true that the loan amount is between 2,500 and 10,000? The answer to that is yes. So now I'll do this. And is it true that if I pick a higher amount, let's say that I pick 20,000, in this case the loan amount is greater than 10,000, so I'll do this one right here. So that allows me to either make a calculation based on a small loan, a medium-sized loan, or a large loan. So let's see what a small loan would be. So now the situation that I have here is, given that I'm in here, which means I'm in a small loan, so the conditions that I'm going to use are this right here. Now that I'm in this range, now I ask the user for the number of payments, and then based on the number of payments, I determine an interest rate. So I can say, if the payments are between 6 and 12, interest rate's 8%. You can get the idea. 13 to 36, 10%. 37 to 48, 12%. And then I return here. Let's look at this at the small loan. So I'm on the calculate payment for a small loan module. I know it's within a small loan because that's how I got here. And now it says if the number of payments is between 6 and 12, the interest rate is 8. If it's not between 6 and 12, evaluate if the number of payments is between 13 and 36, the interest rate is 10, and then exit. And if it's not between 13 and 36, if the number of payments is greater than 36, then the interest rate is 12. So the purpose of this right here is to calculate it really calculates the interest rate on a small loan. Now notice this, calculate payment on a small loan, calculate payment on a medium loan, calculate payment on a large loan. Notice how similar they are. The only thing that's different is the interest rate for the duration. See that? See how they're changing? Very small amount. The logic is the same. Okay, so let's go back to the main. So based on what I have here, so right here I got the user to give me the number of payments and the loan. And then I calculated the interest rate. Here I calculated the interest rate. Here, I calculated the interest rate. Now, one of the things that I would do is I would want to actually calculate the payment. So I would put another, this is not done because I didn't want to give you a fully complete project. So now I would take this and put it in here. And I would say, oh, it's running right now. So I would say that I would want to calculate So what I did is I just made a new module, and the module that I would use here is the very same logic that I used in Programming Project 1. That equation that I had from Programming Project 1 would be what I put in here. Then when I move back to the main, now I print the results. And what I've done here is I've done one full run through one payment calculation or one loan payment calculation. Now, what's missing? What's missing is the prospect that as we go here, use a loop to allow the users to enter as many sets of data as desired. At the end of each loop, ask the user if he or she would like to exit the program. If the user wants to exit the program, if the user chooses not to exit the program, clear the variables and repeat all the process. Now, here's why I didn't do that at this point. I'm trying to work with you carefully to come up with, here's why I didn't put the loop in on the main, although there should be a loop that goes from right here, this point right here, down to this point right here. So you would put that within a loop. The reason I didn't do that is because I want you to realize that there's a technique to building the project in steps. So first of all, when I built this, first thing I did, initialize the variables. Next thing I did, I created a module to print welcome. Next thing I did is I asked for payments. And if you notice, when I go to get payments, I've actually put the logic in there to make sure I validate the input. So typically what you want to do starting now is if you have input asked of the user, then you want to validate it. As I go back to the main, then I see how I'm building these things up. So now that I have my inputs, now I want to move to the next part. And the next part is, I might just want to do this part right here and make sure this works, make this module work. And now if I've got this one working, it's a little bit easier to then do this one and then do this one. Then based on having all the data I need, I can calculate the loan payment, and then I'll print the results. But the important point to take away is you don't build the whole program all at once. You build it in steps and you check it frequently. Build it in steps, check it frequently. And then once you have it working all the way through one time like this, then you could put all this code in here in a loop. And then that loop would say, do you want to continue? If the answer is yes, you continue. And if the answer is no, then you exit. So let me stop there and revisit what we've done here. I tried to give you a path to how you would build this particular project. Now what I'd ask you to do is, if you had problems with it, if you didn't have problems with it, throw the project away and start brand new. And in some cases that's a best practice, because when I can almost guarantee you that when you sit down to write the code again, you'll understand so many things much better, and your code will be more elegant, more easily tested, clearer, and you will feel better about it because you'll feel more in control of the logic. So that completes this discussion. If you have any questions, let me know. Thank you.